right, can everyone hear me all right? Oh, I can't really see y'all. Awesome. Well, good morning. It is 8:30, and I'm a very punctual person, so I like to start right on the dot. Welcome to reInvent. Thank you so much for picking our session today to be hopefully what I think is your first session of reInvent 2024. 8:30 in the morning, you guys are all troopers for getting here, but it is the very beginning, so we're not quite tired yet from walking all around the Vegas Strip. So today we're going to talk about real-time, and because our session is focused on real-time, we're going to start with some real-time audience engagement. So raise your hand if you own or operate an application that has some type of real-time requirement. I'm going to cover the light so I can see. Awesome. Okay, I see a bunch of hands. So y'all are in the right place. Let me do one more real-time audience engagement before we dive in. Raise your hand if you have ever struggled to implement real-time. You run into some of the complexities of managing infrastructure, operational overhead, and that kind of was a blocker to you implementing it. All right, I see some hands as well. So you are also in the right place. And if you didn't raise your hand for either, maybe you're thinking about implementing real-time in your application, you're all in the right spot today. And it's not uncommon for developers to run into these challenges building real-time infrastructure. Right? There's a lot of things that go into managing the infrastructure itself, building custom code to handle authentication, authorization, message handling, and a bunch of other stuff. And so my hope for you is by the end of this session today, you will learn about patterns for building real-time into your applications, and hopefully understand why AWS AppSync is a great tool for you to build that. My name is Kim, and I'm a solutions architect at AWS. I'm joined by Bill Fine as well, who is a senior manager of product management for AWS AppSync. Bill's going to join me a little bit later in our session. This is what we've got for you all today. So we'll start by talking about real-time experience use cases. So this might be helpful for some folks who are thinking about real-time, how they might build that into applications. This will hopefully spark some ideas for you of where we're seeing our customers build real-time today. And we'll talk about some of the common challenges with the existing solutions that exist around real-time. We'll talk about some of the limitations that exist, and then we'll kind of roll into AWS AppSync events, which is a relatively new launch within the AWS AppSync world. And then I'll hand it over to Bill to talk us through some real-world, real-time architecture patterns, as well as what's next. We've got some live demos for y'all today as well, which should be super fun. So make sure you have your phones ready to scan a QR code as we go through today. All right, so there's a lot of examples of where real-time can really enhance user experiences. And one of those kind of broad use cases is event broadcasting, where you send updates out to many subscribed clients, and they all get those updates in real time. Imagine that you are a die-hard Seattle Seahawks fan, and DK Metcalf just scored a game-changing touchdown. Would you want to hear about that immediately or a few minutes after it happens? And this is actually a struggle when it comes to real-time events. It would be awesome if you got that update right away so that you're not behind when everybody around you starts cheering at the sports venue watching the game. And so that just highlights one of the critical areas where real-time becomes really important to enable those great fan experiences where end fans can feel like they're part of the experience as opposed to being on the sideline and not getting those updates as they happen in real time. Another example here might be inventory availability, where you have been eyeing the high-end Instant Pot on your favorite e-commerce website. You go to buy it because it says items are in stock. You get really excited, only to have an email get sent to you an hour later saying that item's actually out of stock, right? That's a bad user experience, where you want to get that inventory availability up to the second while your users are shopping on that e-commerce website. So both of these are examples where event broadcasting out to many connected clients really benefit from those real-time user experiences. But we also see examples in real-time collaboration use cases. You can think of this as two clients interfacing together and real-time enabling that communication. A good example here is multi-turn gameplay, where you're strategizing with another player and you're feeding off of each other's moves. One player makes a move and you don't get updated about that, that can really impact your overall strategy for the game and reduce the experience that your users are having as they're interfacing. Another example here might be a call center, where you have many agents working on tickets, and if they're not updated in real time to say an agent has taken a ticket, another agent might start working on that ticket, and you have duplicated effort, inefficiencies, and again, that's just not a great user experience for your clients, as well as the agents in your call center. So this is really to kind of underscore some of the examples that we're seeing our customers start to implement when it comes to real time. And kind of just to talk a little bit about, some of the things that we're seeing be the pain points for customers building these out themselves. And there's really three kind of struggles that we see customers face. A typical pattern today for implementing, I'll call it semi-real-time experiences, is polling. And if you're not familiar with the polling pattern, this is essentially where the client reaches out to the server and says, hey, do you have updates for me? Hey, do you have updates for me? That experience puts a lot of onus on the client implementation, right? You're essentially limited at that point to how frequently the client fetches to your backend asking for updates, which can lead to increased latency. If you're reaching out every 15 or 20 seconds for updates, you might not get those updates until 20 seconds after they actually happened. Additionally, this also leads to unnecessary resource utilization. Every time your client reaches back to your server and asks for an update, there has to be some type of compute that's running to answer that request. And if there's actually no update that happens, unnecessary spinning up of serverless compute or containers to handle that request, even if nothing has changed. And then lastly, we see this result in a lot of scalability challenges. One client pinging the server asking for updates, that might not be that bad. But if you have millions of diehard Seattle Seahawks fans pinging the server saying, hey, do you have updates on DK Metcalf for me? That can be a real challenge from a scalability perspective. We do see some customers take the approach of implementing their own WebSockets. And WebSockets have their own level of complexity. One of those complexities is around connection management. And so essentially what we mean here is managing who the connected clients are to your application, being able to track when they're connected, when they're disconnected, uniquely identifying them via connection ID, and then how do you actually send the updates out to them via a message fan-out pattern where all of your connected clients need to get those updates. Again, this might be simple if you have one WebSocket server, right? It's not too bad to manage that. You have a database somewhere, you have some compute. But as you start to scale that across many WebSocket servers, connection management and message fan-out become even more complex. And then all of this results in more backend code that you need to write. And if you're like me and any code that you write is a liability, you want to reduce the number of lines of backend code that you need to write. And so we often see customers implementing custom pub/sub authorization modes, different code to handle messages, filtering, transformations, as well as the enterprise features that we need for these applications like logging and metrics. And so all of this to say is that these traditional real-time architectures require a lot of heavy lifting and non-differentiating code, right? Code that is not specific to your business, but is required to run these applications. So we do have some options for building real-time experiences on AWS today, and a lot of our customers leverage these patterns. The first of those is Amazon API Gateway WebSockets. If you're not familiar, API Gateway WebSockets are fully managed WebSocket APIs that enable two-way WebSocket communication between clients and subscribers. The connection management and message fan-out piece of this solution is a bit do-it-yourself, right? You actually have to track who your connected clients are via a specific connect route, store that information in a database somewhere, and then handle the message fan-out yourself by iterating through who all needs to receive those updates and then sending them out via the post-to-connection API call. We also see customers using AWS IoT Core. And if you're not familiar, AWS IoT Core actually uses MQTT messaging protocol, and it provides a managed broker to enable that communication. IoT Core is really great for IoT device communication, and the reason for that is because MQTT is very lightweight, and it provides a lot of the security features like X509 certificates for enabling those experiences. And then the last solution that we'll talk about, which some of you might be familiar with, is AWS AppSync GraphQL. And AWS AppSync GraphQL provides a fully managed GraphQL and WebSocket API for you to use in your applications. And the part of AppSync GraphQL that enables those real-time experiences are what are called subscriptions. And subscriptions are a result of a GraphQL mutation, which is a data modification step. And so this solution does require a little bit of expertise when it comes to GraphQL, right? You actually have to write the schema, but you do get the benefits of fully managed connection management, built-in message fan-out and broadcasting, which is a great option. But customers asked us for a different solution, and they specifically asked us for a purpose-built pub-sub solution for building these real-time experiences. And because we're Amazon, we love data, and so if you don't believe me on this one, I'm going to rewind us 1 year to a session very similar to this one. We're up on stage. I think Bill and Ryan, one of our other presenters, asked this question to the audience. What would make AWS AppSync real-time subscriptions even better? And vastly, the majority of folks said a standalone event API with no GraphQL required. And that is exactly what we did. At the end of October, we announced AWS AppSync Events, which is a new service designed for building real-time experiences at scale. It's a fully managed pub-sub service with built-in authentication, client connection management, broadcast capabilities for that message fan-out that we talked about earlier, point-to-point communication as well, and message transformation. We really built this to reduce the operational overhead of building and managing these real-time experiences, while all focusing on enabling application performance, right? So you get the benefit of a fully managed solution with the simplicity of getting started in just a few clicks. And because this service is one of our serverless services, you only pay for what you use, and you can scale as your application usage scales from a cost perspective. So how does this work? It's pretty simple. We have publishers on the left side of the screen. Your publishers can be your application clients. These can also be back-end event-driven services like Amazon EventBridge or even DynamoDB with something like DynamoDB Streams. These publishers are publishing out over an HTTP post API call. And then on the right-hand side, we have our subscribers. Again, our subscribers can be application clients, or they can also be event-driven services as well. Your subscribers connect over a WebSocket to the API. In the middle is AWS AppSync Events, which is providing that WebSocket infrastructure for you behind the scenes with built-in connection management and the ability to do message fan-out. We're going to talk in a little bit more depth about the middle piece, which is namespaces, channels, and segments, a little bit later. But I figured now might be a good time for a demo. So I'm going to go ahead and switch over to this slide. And now's where y'all are going to get out your phones and go ahead and scan this QR code. I'll give you all a few minutes before I switch over to our demo screen. Check in here to see if I've got most phones down. All right, I'm going to switch over. All right, and go ahead and start clicking away on all those different emojis that you see. And this, again, is a live demo. So what you're seeing in real time is AWS AppSync Events in action. We're getting a ton of emojis coming through on our display here. And hopefully we are able to get all of those through. You guys are picking some good emojis. Awesome. So that is a live demo. Well, why don't we talk about how this actually works behind the scenes? So you saw up there that we had these 2 bits of code. So on the left-hand side is the code that you folks are interacting with in a lightweight React web application that you accessed. And so on the left-hand side, as you're clicking an emoji, we're actually interfacing with our AppSync event API via a publish operation, which, like I mentioned, is powered by HTTP post under the hood. The syntax itself is using a namespace channel namespace at the bottom. That's that reinvent emoji. We're going to talk a little bit about that later. And we're essentially just sending a JSON payload with our emoticon included. And then on the subscriber side, that was the application that I had up on my screen. That was listening for those updates on that same channel namespace, the reinvent slash emoji channel namespace, and displaying it and rendering it for you on the screen in real time. This code is provided by the AWS Amplify API client library. But again, because we're just using HTTP post for publish, as well as WebSockets for subscriptions, you don't have to use Amplify. You can use your favorite HTTP or WebSocket client library. Amplify does make it very straightforward. I think this is roughly 20 lines of code. And again, if you're like me, the less code you have to write, the less liability you have in your applications. And again, our application here is very simple. You have your application on the phone. I have my demo screen up here. And AppSync Events is the only service we're effectively using in our application. There's some ancillary services for hosting the apps themselves, but the actual infrastructure that's powering this real-time application is AppSync Events. So let's talk a little bit more about how AppSync Event APIs work. So channel namespaces, or namespaces, are something that I've mentioned a little bit so far. And these are really core to the AppSync Events service. Think of these as the channels that are available on your event API. And the namespaces themselves provide the capabilities and behaviors of these channels. So channel namespaces essentially are meant to provide you a scalable way to define how your publishers and subscribers are interacting with your API. And namespaces are meant to kind of centralize the configuration for those specific channels. The channels themselves are ephemeral. And so the only thing that you need to create upfront is the namespace. Let's take a quick example from our slide here. So up at the top, we have namespace A. And a namespace is essentially the first segment in that path with all the backslashes. And so anything that has a /A at the front of it in terms of the channel is part of namespace A. And then the /ABC, /DEF, /XYZ, those are all individual channels that we create on the fly. As soon as a publisher publishes out to those, that gets created. And then, as you subscribe to it, you're able to interface with that specific channel. But they're ephemeral, right? So they go away when you no longer need them. So that gives you a lot of power in how you segment out the messages that you're sending inside of your application. Similarly, for namespaces, I mentioned that they kind of house the configuration and behaviors for how your users are interacting with that specific namespace. Every namespace has different handlers, event handlers that you can configure for interfacing with publishes and subscription requests that come into that namespace, as well as the ability to override the authorization defined for the API. We're going to dive into both of those separately to give you a bit more example of how those can be leveraged within your API. So event handlers, we've got two. Well, the first we'll talk about is the publisher path. So your publisher publishes out events to your API. Those can be intercepted via this onPublish handler. And handlers within AppSync Events are written in JavaScript using the AppSync.js runtime environment. And a couple of use cases that we are thinking about here for how customers can leverage this are for things like event enrichment. So, adding in additional fields after that message has been published, so that you're not putting that onus on your client to include all the information. We can kind of do that as a post-enrichment step when we receive those events. Other use cases that we're thinking about here are things like event schema validation, so enforcing a specific structure to the events that your publishers are sending. And then in addition to that, things like event filtering, being able to reject certain events as they're coming through if they don't meet that schema validation, or if you just don't want certain types of events to be sent out to your subscribers. The same is true for our subscriber path. So a subscriber goes to establish a connection to our API. They'll first hit this onSubscribe handler. And some use cases that we're thinking about here are granular authorization. So only allowing subscribers to subscribe to specific channels. Maybe if it's a channel that includes their username, or maybe it's a channel that includes a group that they're a part of. And additionally, being able to filter those subscriptions if those authorization rules are not met. So I mentioned that we're using the AppSync JavaScript runtime here. So the utils that you might be familiar with in your resolvers today with AppSync GraphQL, that's the same type of environment that we're using here for our event handlers. The one on the left that I'll show first is an example of a publish handler. So with the publish, you can actually send one or a batch of up to 5 messages, which is why in the export function on publish handler at the bottom, you see we're actually doing a map for all the events that were received as part of this batch. And then we're running an enrichment step. And in this enrichment step, we're adding a couple different fields to each event that we're getting. So a timestamp to say when we received this at. We're also adding the event that we're at, as well as the session ID. And so again, these are things that the client doesn't have to explicitly provide when they're publishing out this event, but things that might be helpful for us to include for tracking and different things later on. On the right, we have a subscribe handler. And here, we're essentially checking for group membership when a client subscribes to a specific channel. That channel needs to include a group that the subscriber is a part of in order to be authorized to enable that subscription. So these are just a couple examples. I think there's a lot of really great use cases that we'll start to see customers build for event handlers, but there's a lot of flexibility, so definitely interested to see what y'all go build here. All right, let's move on to authorization and authentication. So just like all of our other services at AWS, security is job 0. We have 2 different security configurations from an authorization and authentication standpoint for AppSync event APIs. The first is at the API level. So this is what is essentially the default for the API. There is a connection authorization mode. So this is essentially for establishing the initial WebSocket connection. And you can configure this independently of the authorization modes that are used to support publish and subscribe operations. But at the API level, there are defaults that you can set. So a default set of authorization modes for publishers and subscribers. But these can be overridden at the namespace level. So if we go back to our emoji thrower example, we have a /reinvent namespace that we define, and we can actually override the publish and subscriber modes that are supported for that specific namespace. So a use case here might be, you might have a more public namespace where you want users or clients to subscribe to that via API keys. But then you might have a more private namespace where you only want authenticated users via OpenID Connect to establish that subscription. And you can do that using the namespace level auth overrides. I mentioned 2 so far, but AppSync Event APIs supports the same authorization modes that AWS AppSync GraphQL supports. So that's Amazon Cognito user pools, OpenID Connect, AWS Lambda for any type of custom authorization that you might have that's not supported out of the box, API keys, and AWS Identity and Access Management for role-based authentication. And just like AppSync GraphQL, you can combine and mix and match these modes and have multiple at either the API default level or at the namespace publish and subscriber override level. All right, so I'm gonna go ahead and summarize the key benefits that we've talked about so far, and then I have one more demo before I hand it over to Bill. So there's kind of 4 things that we're seeing as benefits for AppSync Event APIs. The first of those is being able to start really fast and get up and running with a enterprise-grade real-time API solution. The whole goal is to be able to configure this API in minutes. So your application teams can go to your backend teams and say, hey, I need an API that can power real-time events. And the backend team can spin that up in a minute and get them over the endpoint so they can start building it into their front-end application. We made it really simple to interface with these APIs via publish, via HTTP post, subscribe, via establishing a WebSocket connection, and providing base code to get started with right in the console, which I'll show you in a bit. The second benefit that we're seeing is customers have the ability to go to any scale, right? And this is really a key component when we think about getting started fast, but also being able to have that enterprise scale within our API with extremely low latency and default quotas that support those scale. As a default quota, you're able to scale to 1 million messages per second with your AppSync event API. You have the ability to deploy these APIs to 30 global regions, as well as the enterprise features like custom domain support, AWS Web Application Firewall integration, as well as logging and metrics powered by Amazon CloudWatch. Because we're managing things like connection management to the API, message fan-out, we're reducing the overall operational overhead that we talked about earlier in the session today that we often see customers face when they try to build out these solutions themselves. We provide those authorization modes so you can essentially plug and play and get fully baked authentication without having to write any of that custom code. But we also give you the ability to write those event handlers for doing message filtering and enrichment for your specific use cases. And then lastly, because this is serverless, the whole goal here is to hopefully help you reduce your overall cost and help you grow as your application needs do, and then help you get started really quickly with the service at a low cost with our free tier, as well as roughly $1 per million API operations. All right, so I said I'm going to do one more demo before I hand it over to Bill, so I'm going to go ahead and switch over to that quickly. All right, so I'm going to go ahead and try to prove that first statement that I said before. You can start really fast. So we're going to see how long it takes us to create our first event API. So I'm over here in the AWS AppSync console, and I'm going to go ahead and click on Create Event API. We'll call this Emoji Demo Live, and I'll go ahead and click Create. That's it, all done. No, we have a little bit more that we can show, but we actually just got a fully baked API that we can go ahead and start using. And if you don't believe me, I'm going to go ahead and jump over into our pub sub editor. And our pub sub editor is a way for you to test your APIs in the console to verify that your authorization works as expected, your event handler code works as expected, before you take that next step and integrate it into your application. So we have two different sets of panels here. We have our publish panel, which is where you publish your events. And then down here at the bottom, we have our subscribe panel. By default, when you create your API, you get an API key as the default authorization mode, again, to enable you to start fast. So I'm going to go ahead and establish my WebSocket connection. And you can see down here that we have logs as well showing what we're doing. We're establishing the connection, and we also have a connection ACK coming back from the service. And then we can go ahead and establish our subscription to our specific channel namespace. Again, by default, when you create your first API, you have a default namespace that you can use to play around with. So I'm going to go ahead and just subscribe to this default namespace /test. Test here is my channel. Again, I have my subscribe request and my subscribe success message back. If I jump back up to my publisher, similarly, we have our API key configuration for auth. I can go ahead and switch over to my test channel that I created. And down here in the editor is where you can actually put your JSON payload events. Here we have 2. You can go up to 5, or you can just send a single one if you want to. I'll go ahead and click Publish. I get my publish action as well as a response, which gives me a unique identifier for each event that I send. And if I come down here, I should see 2 separate events that I received via real-time subscription that I established earlier. So within maybe roughly 2 to 3 minutes, we were able to get our API set up and test it. We'll maybe do one more example to show how you add a custom namespace. So I'll jump over to my namespace over here. I'll create a new namespace, and I'll call this one reInvent. And in here, this is where you can override the authorization, like I mentioned before, at the namespace level. The API itself right now only has API key, so it doesn't make sense for us to go in and do this. But if you wanted to, you can add more authorization modes that can be leveraged at the namespace level. But why don't we go ahead and add an event handler? So this is what our event handler editor looks like. We have our onPublish handler here, and we have our onSubscribe handler here. Let's go ahead and add in some live code, because live coding during a demo is always fun. And we'll go ahead and import our AppSync utils library. This has a bunch of useful utility code for interfacing with strings as well as datetime utilities. And we're going to go ahead and add just a couple fields here. We'll go ahead and add this updated app field where we'll do util time, and then we'll get the current time. And then we might add one more, like event, which is reinvent 2024. And then we might add one more session survey. And we'll say this is a great session. Awesome. So that might be good for our onPublish handler. But let's also look at implementing something for our onSubscribe handler. So here, what we can do is we can restrict our subscribers to only subscribe to the emoji channel that we used in our demo. So for that, what we can do is say if context.info.channels.segments.includes, and then we'll call this emoji. Hopefully I spelled that right. And then we will go ahead and do util unauthorized. And if not, we'll return context. So essentially what I'm doing here is I'm checking the segments that exist within our channel includes the emoji code or the emoji segment or not. And if not, return util.unauthorized. And hopefully all that code is correct. It should yell at me if it's not. So that all looks good. Let's go ahead and test that specific namespace in our PubSub editor. We're going to go ahead down to our subscription. We'll go ahead and connect. And then let's go ahead and try the failure case first. So we'll say this is not valid. This should return an unauthorized error if all my code is correct. And oh, I have a code error problem. That's my bad. I probably spelled something wrong. This is what always happens in live demos. So we'll go ahead and edit that. We're going to go ahead and just we're good. I think that was correct, but we'll just uncomment it for now. Essentially what we should expect there is an unauthorized for anything that's not emoji. I'll go ahead and share the correct code after, but let's, for the sake of it, just go back to our demo. We'll establish our connection again. We'll subscribe to emoji, and then we'll go ahead and send out our events on that specific channel. We can publish both of those and see them both here at the bottom, but just for fun, let's go ahead and add some custom emojis and send all of those. And if we come down here at the bottom, we should see each of those come through with the additional metadata that we added in our onPublish handler in our event enrichment step. So that's it for the demo. I'm going to go ahead and hand it over to Bill to take us through some real-world, real-time architecture patterns.
Thank you, Kim. And I thought, wasn't it great how she worked in showing how you can catch errors in your code using the PubSub editor so quickly? So I thought that was great that you did that, Kim. And so now I just need to figure out which one to press to move the slides forward. Here we go, the big green button. So I'm Bill Fine, and I manage AppSync product management. And as we started developing AppSync events, we had two basic tenets in mind. We wanted to be simple, and hopefully you just saw that from Kim. In a little over 20 minutes, she talked to you through what it was, gave you a demo, showed you how to build something meaningful with just 20 lines of code on the client side, and then create the actual event API with some custom configuration and test it in just a couple of minutes. The second design principle we had in mind was, while we wanted it to be simple, we wanted it to not be simplistic. So when we designed, what we had in mind were mission-critical real-time event patterns for organizations that were building their real-time applications for things like the Super Bowl or the Olympics or today, Cyber Monday or Friday, Black Friday, these kinds of applications. So what I want to do now is dig into how some of those kinds of organizations are using this solution, what their real-time patterns look like under the hood. And Kim mentioned event broadcasts. That's the first one I want to dig into. So event broadcast is a pattern where you've got one or maybe a couple of publishers on the back end. Typically, these are server side or back end side that need to publish to, could be thousands or tens of thousands or hundreds of thousands or even millions of connected clients or subscribers. And so it could be a wide range of things. And so maybe this morning you checked your stock portfolio or the price of a particular stock from your financial app. Or maybe you're a crypto person and you've been trading meme coins while you've been listening to Kim and I talk. Maybe it's Cyber Monday and you logged on to Amazon and Amazon Live, which if you don't know Amazon Live, it's a video channel where you can go listen to influencers share with you what you should be buying today on Amazon. And within that, they will include the prices and the inventory availability in the video feeds, those kinds of things. Or maybe tonight, after all the sessions, you want to go to the Sphere and you're looking up and you're trying to pick your seat from available seats. Or maybe you can't get a seat and you're back at your hotel room and you're watching your favorite music reality TV show. And you're on your phone waiting for online voting to be signaled to begin or to end. These are all real-time patterns that we see for event broadcast. But probably the most paradigmatic example is sports. Sports scores and stats. Kim's obviously a Seahawks fan, so she talked about DK Metcalf. The example I'm showing here is from the PGA Tour. And is there anybody from the PGA Tour here today? Not today. All right. Well, so there's a QR code here that you can click, and this is going to be a short video from the PGA Tour showing how they use AppSync to support their fan experience applications. And so if you're a golfer, maybe you're familiar with this. And just as an aside, you might be asking a question. So if you dig into this video is from a year ago, and we just released AppSync events 4 weeks ago. So why am I talking about the PGA Tour? And so just as an aside, the PGA Tour stood up here with me last year and presented on how they were using AppSync GraphQL subscriptions to power their real-time needs. So you remember that was one of the options that Kim showed at the beginning of her presentation. And they talked about how great it was and how it was servicing their needs. But privately, what they told me is they said, we really want a simpler solution. GraphQL, is good for some use cases. They understood that, but they really wanted just a pure pub/sub solution, and that was the genesis of creating AppSync events. And so, if you end up loving AppSync events, you think it's something great, you run into somebody from the PGA Tour, tell them thanks, because they were the ones that started that conversation. But if I look at what they were doing, to dig one level deeper in terms of how they manage their events. So if you're a golfer, you may know this. If you're not a golfer, which I'm not, I'll try to explain it. But during a tour event, what they'll have is typically groups of 4 golfers on one of 18 holes, or maybe on 36 if they're across 2 courses. And they've got people spread out on each course with mobile devices, capturing what's happening on that particular hole. So how many strokes a golfer has hit, maybe how far the ball has traveled, where on the green the ball is, and they're feeding that all into a DynamoDB database from those devices. And they've configured DynamoDB streams to send those events as they occur up to a Lambda function that's listening for those changes and then writing those events to AppSync. In their case, it's AppSync GraphQL triggering subscriptions. But if they had had their way a year ago, it would have been AppSync Event API. So publishing those events to AppSync, in this case, to update what might be leaderboards on the course. It will be video or the broadcast channels, the things that you see in the broadcast channels in terms of the status of the scores or the stats. It's the fan experiences that I mentioned, so the web and mobile applications that the different fans of the golfers look at, and so they might subscribe to their use a channel mechanism to be able to see what's happening with their favorite golfer, not all golfers, or even things like they're also updating all of the betting platforms that are, people are using to bet on what's going to happen next in the golf tournament. And so that's, a very typical kind of pattern. And since I mentioned betting platforms, so I flipped the screen. I don't know, there's not too much different here. There's two differences. One is the use case. And so now I'm talking about odds or price updates. And so the odds use case, we're talking to a number of different customers that are using this pattern to provide the folks that are placing bets through web or mobile applications on any wide range of different events while they're happening, to update those users with the most current odds, which they might be changing every 500 milliseconds or as quickly as that. But basically the same idea. The difference here in some of the examples I'm seeing is instead of using DynamoDB streams, I'm seeing customers use Kinesis or maybe manage Kafka as their event source, and again streaming that to a Lambda listener that's then writing that out to AppSync Event API to broadcast it out to what could be hundreds of thousands or millions of connected subscribers. And so, well, that's pretty easy, right, in these two cases, handling, in scenarios handling billions of messages to millions of customers with a couple services, excuse me, from AWS. It can be even simpler in some cases. So EventBridge, if you're not familiar with it, is part of AWS's serverless portfolio of products, and helps you build an event-driven architecture. But so what you can configure with EventBridge is an event bus to hold your events. And if you have one of these, you can pretty easily configure your EventBridge event bus to talk to AWS AppSync event APIs by configuring what EventBridge calls an API destination. So now we're down to just, from three, sort of an architecture with 3 boxes on it to 2 boxes. So lots of things that you can do here to implement at scale this broadcast pattern. The second pattern that Kim touched on that I want to talk about is a collaborative pattern. And this is typically, instead of just 1 or 2 publishers, you've got a broader number of publishers that are interacting with a more finite set of subscribers, kind of a collaborative fashion. So that could be a wide number of things. So any kind of group chat experience, maybe you're on Slack this morning, something like that. It could be collaborative document editing, or you're on a shared document, on a call, adding comments, making changes, seeing changes as they happen. It could be a support ticket that maybe you're working on across different teams where assignments are changing, updates are being made. But another example, probably the paradigmatic example, and maybe a few of you are doing it right now, is playing a game. And so here's an example of a Connect 4 app that we have, and there's a little plug here for a session that's coming up later this week, for a workshop that'll walk you through creating this app with AppSync events. So that's the good news. The bad news is I'm pretty sure it's all full right now, so hopefully that's not too bad news, but stay tuned for a second. I've got some good news for you. But in this case, this pattern, as I mentioned, is really app to app. So the applications themselves, the clients, are acting as both the publishers and the subscribers. So alternately publishing over HTTP their updates or their moves, or in this case, and then receiving notice it's their turn to move, and then publishing their moves, those kinds of things. Now, I mentioned there was a little bit of good news. If not being able to go to that session was bad news for you, you can scan this QR code, and that'll take you to a blog that has a repo that will show that Connect 4 app, creating that Connect 4 app. It's a Next.js app running on Amplify hosting with an AppSync events backend that'll show you how to do a game like Connect 4. We'll use that example to support turn management, gameplay. It's got an ephemeral leaderboard built in to show stats, as well as a group chat to allow players to talk to each other. All those real-time patterns powered by Event API. So it's kind of your cheat code if that was interesting for you. So there's a lot you can do with AppSync events, just built-in capabilities with little or no configuration. There's a couple of advanced patterns that I see within our customer base that I want to talk a little bit about as well, that require a little bit more, hopefully but not a lot more. So AppSync events, if you didn't realize it, so far it's stateless, and so we don't persist events within AppSync events. And there's many use cases where that's okay, but sometimes you need to be able to persist and access the events. And here's an example of how you would do that. Now, why you might do that, typical example would be if somebody's connecting to a subscription, you don't want them to wait for the next update. You want them to actually query for the last update and then start receiving updates from that point. Or maybe they've disconnected and they need to reconnect from a point and replay some of the messages. And so one way to do that, there's multiple ways, is that as your publisher is creating that event, they're also persisting that event into some kind of data store. And so in this example, I'm showing a simple sort of API pattern backed by RDS, could be DynamoDB, could really be anything, that then your clients, when they come online that are trying to subscribe to an event stream, can query to get the current state. Another example, and Kim really just demoed this, was how to add event order. So we don't guarantee order in the delivery of the events through AppSync Event API. So what you would need to do, something like Kim just did, which was leverage the AppSync utilities to include a timestamp to transform your event as it flows through to give something for your clients to be able to reason about order. So that's an example of how you might do that. It's a relatively new service. I'm starting to see almost every week now members in the community come up with patterns, additional patterns like this. On the way down here last night, I saw an AWS community builder had published a pattern for how to achieve guaranteed delivery with AppSync events, and in that case, event bridge schedulers, S3 and Lambda. So lots of interesting things that people are doing in the space to address some of these advanced use cases. So AppSync events is relatively new. It's 4 weeks old. It's got that sort of new service smell, I guess you would say. And that might make some people nervous. Could I really use it? Is it ready to be used? I'd say the answer is unequivocally yes. The reason for that is that we built it on top of the infrastructure, sort of the battle-tested infrastructure of AppSync GraphQL subscriptions that are managing billions of events every day. And that's allowed us to do this. And so when we launched AppSync events, the default quotas that you have are 1 million events per second outbound, 10,000 events per second inbound, and then there is no number of connections limit, so you can have unlimited number of subscribers, but there is a throttle on the number that you can create per second. So it's 2,000 new connections per second. All these are adjustable, but pretty heavy, hardy defaults that most of our customers can get started with. It's available in 30 regions, so that's important, particularly in this use case, so that you can place your event API close to your users to reduce latency. Now, it's difficult for us to talk or publish latency numbers because everybody's use of it is a little bit different. But I can share that what we're expecting, or so what we expect to see for a basic use case is that your P50 latency metrics should be in the 50 milliseconds or less domain, and the P99 would be 200 milliseconds or less. And if it's not, let us know. We'll take a look. From a cost perspective, it's pretty simple. We charge $1 per million event operations. So that's an inbound message, it's an outbound message. It's a WebSockets operation like Connect. We also charge per connection minute. It's 8 cents per connection minute. Most use cases, 95% of the cost is the event operations, and it's not in the connection minutes. And so, but there are edge cases where connection minutes can matter. And then to get started, we include 250,000 event operations and 250,000 connection minutes per month for the first year, so you can get going quickly and try it out and see if it fits your use case. So where are we going next with AppSync events? Couple of different things that we're working on. Some of our customers have asked us for private APIs, and so they want to place their real-time patterns. Most of what we've talked about is public, but there are customers that want to place this within the context of their VPCs, so that publishers and subscribers are placed within that secure environment. So we're working on that. We told you that you published today over HTTP. We're working on adding publish over WebSockets. So you'll have a full duplex WebSocket available to you for publish and subscribe operations. Should simplify the developer experience and then further reduce latency in some scenarios. The other thing that we're doing, Kim showed you Event Handler, and so that's, think of it as kind of like a Lambda-less environment that we run natively within the AppSync service. No cold starts, it's efficient, it's quick. But sometimes you need the power of a Lambda, so we'll give you the ability to eject to a Lambda. And that might be maybe you don't want to use JavaScript, maybe you want to use Python or Go, or maybe you want to, your use case requires some network access that we don't allow with the AppSync JavaScript runtime. So we'll give you that ability. The other thing that we're planning to introduce is what I'm calling built-in targets, or if you're familiar with AppSync GraphQL, you can think of it as data sources. And so what that means is you give your event handler the ability to interact with databases. So we'll support DynamoDB, the Aurora databases, OpenSearch. And that's to further simplify, for example, that persistence use case where you're publishing your event as it flows through the system to a database. Or perhaps you want to call those databases to augment the event with additional data. We'll support EventBridge as a destination or as a built-in target if you want to send an event that's generated perhaps from an application event that's happening and flowing through the system in addition to the subscribed customers, but to your back-end EDA architecture. And we'll support HTTP APIs, so you can interact really with any API through your handler. And then the final thing that we plan to support as a built-in target is AWS Bedrock or Amazon Bedrock. And so I will say this might be, I know this is one of the first sessions, but keep track of this. I think we've gone through almost the whole session. That's the first time we've mentioned Bedrock or generative AI. And you might be saying like, well, how does that even fit in this use case? But so look, imagine this scenario that you're an application publisher, and maybe what you are, your application, you're a financial services organization or insurance organization that wants to provide your users the ability to interact with a back-end model to ask questions about their policy, for example. So they might say, natural language, does my policy cover X, Y, and Z? And then publish that as an event through an AppSync event API over a WebSocket that they connect to. And then have the handlers kick in to do things like augment, a little bit of RAG, to augment that prompt to say, maybe call out to a database to pull that particular user's policy and send that on in the handler to Bedrock, which can take that initial question, the user's policy, generate a response, and then send that response back onto that same event channel, same WebSocket as a response back to the customer. So we think that's an example of how people will be using AppSync events in the context of a generative AI use case. So the other thing that we're working on is I shared a lot earlier of things you could do. This is how you could manage event persistence, and this is how we'll make it easier with adding data sources or built-in targets for you to manage that through your event handlers. But why don't we just do it for you? Right, so that's the next step here, is to have built-in event persistence options for you within the AppSync events service itself. Built-in order, again, we showed you how you could do that, and it's not that complicated, but why don't we just do that for you? We didn't talk about this, but presence detection, things like that are another, and that's like, the little green dots you see, is somebody actually listening to this channel or not, when you're in a group chat scenario. Or things like event schemas and event schema validation. Kim talked about how you could use event handlers to validate a schema. What we're thinking about doing here is giving you the ability to create typed events. Maybe using something like cloud events, and then having the server itself manage the validation. So lots of different things here that we're working on. I want to sort of go back to that little analogy I gave with the PGA Tour where you see that they had a very big influence on our roadmap. And it was them and others that were coming up to me at reInvent, talking to me about what they wanted to see in the product. So if you see some things here you like and you want to make sure that we do work on them, let us know. Let me know if you see some things missing from this slide that we should be working on. Let me know. We really want to listen to you. And so that's it. Hopefully you've seen how easy it is to get started. That's something that fits your use case. There's a couple of QR codes here that'll provide you the documentation, but it really is pretty simple. Just a couple lines of code. Get in, start testing it in the free tier, and let us know what you think. And there are a number of sessions coming up related to what we've talked about today. They'll dig deeper or show some other examples that are available. You can just go into the catalog and search for AppSync, and they'll pop up. I think most of them are full, but if you don't manage to get in on if something that's interesting to you, you don't manage to get in, there will be video replays. And so finally, I want to thank you for coming. First session of the day, probably for everybody. Thank you, Kim, for all the work that you put into this. There is a survey. And is there a QR code for the survey? No? What's that? It's in the app. So go to the app, and if I'll tell you that not just for this session, but for all the sessions that you see we really do pay attention to these surveys based on the feedback that's given. It informs what kinds of content, what kinds of sessions we'll do next year. It informs what speakers present. So if you really like Kim, which you should, she's great, and you want to see more from Kim, give her a great view. If you don't like me, which is fair, let me know, and we'll turn it over to somebody else next year. But do please engage with the surveys. We pay attention. So with that, I think we're done. We thought we might have time for questions, but we don't really. So I'll be available in the hall right after this if people want to chat. Thank you.